Hello, everyone. Let's start our session today. First of all, my name is Osama Abdelhamid. I'm a technical team lead and solution architect. Today, as you can see, our subject, it's a very interesting subject, actually, and it's around Azure Cognitive Services. We are going to start with a small presentation because actually we have a lot of interesting things to demonstrate today. We have a lot of demos. We are going to see the cognitive service and how to build AI services in your applications, actually out of the box without building things from scratch, without building things from ground up. So let's start with the presentation first. Azure Cognitive Service. I believe you can see my presentation now. As you can see, this is actually the landscape for the different services or different categories under the cognitive services. We have actually 5 main categories under cognitive service. The main idea of the cognitive service first is to, as per the definition in the documentation, is to make the computers see, understand, and moreover, take decisions as well. How to do this in practical way? The idea here that we have common AI tasks. These common AI tasks is encapsulated in trained models exposed by Microsoft, and it gives you AI as a service. It gives you machine learning as a service. So if you are a developer or you are someone who has a business and you have a mobile app, and this mobile app that serve your business, you want to extend AI capability within this mobile app to expand your business or to get specific benefit, you can do this actually using something like Azure Cognitive Service, because it really covers all of the common tasks that you might think about, which might be implemented in AI field or machine learning field. The main idea here, as I said, we have 5 main categories. The first category is the vision. Vision, this is the computer vision field where we try to let the computer understand the images and see what is inside the images, and then we can extract the different objects within this image. We can actually describe the image. This is what we call it in machine learning, image captioning. And we can also build some custom vision models. And these custom vision models will be something we will demonstrate today as well, to see the capability of extending the AI actually models without even writing code. We are going to also demonstrate how to consume this from the code. So if you are someone who already coming from any technical background, it will be very easy to you to consume such services because it's exposed to you as a web service, as a REST API. So under the vision, the first category, as you can see, we can see here the computer vision, okay? Custom vision services where we are training a custom model to serve as a computer vision model for a specific domain, okay? We have also face. Face means here all of the things which is related to the face detection, face identification, face verification, face recognition, and also sometimes we need to compare between faces. Suppose you have multiple images and you want to identify across the different images, is these faces are similar or not? Is this the same person or not? And also we can use and extend such implementations for the face service, for example, in the attendance systems. In any workplace, you might need to implement attendance system, and you can rely on the biometric attendance systems, which is widely used these days. So this is one of the very clear implementations for such face service in the cognitive service in Azure. We have also something called video indexer. I believe this change has been changed. This name has been changed recently. The service name has been changed recently by Microsoft. But anyway, the idea here for the video indexer that you want to also to do the same, like what you are doing with the images or the photos. You want to extract information from the videos. Suppose you have a video and you want to detect the faces within this video. You want to make sure if specific activity has been detected within the video, that you can identify this activity and get maybe alert when this activity occurs. Maybe I want to actually identify the impressions or the emotions for the different faces within this video, may I want to also to extract what might be the topics those people in the specific video are talking about. All of this coming under the domain of computer vision, and specifically what has been called recently in Microsoft services by video indexer. As I said, I believe the name has been changed recently, but it doesn't matter. Now you understand the main concept of the video indexer. We have also the second category, speech, where you can actually make real-time speech translation. So on the fly, we can build a model which can translate from German to English. Suppose you are visiting Germany for your first time, and you don't know German, and you want to talk to people. You can make use of this service, for example, to make real-time translation from German to English, and on the other side, the speech in the other language will be translated and will be actually spoken in using a synthesized speaker to express what you are trying to explain to the people around you. Also, in the speech translation, you might want only to take audio file and translate this audio file to a specific language. So I might give you audio stream, and this audio stream has English speakers, and I want to actually translate this, or first take this audio stream and convert it to text. And then I might be interested also to take this text and convert it from English to another language, okay? And so on. These are the kind of the implementations we might have here under the speech service. We have also speaker recognition, which is very common, and it's well known. So if you have specific speakers and you want to identify who is talking, who is the person who is talking in this specific audio, this is also a kind of implementation for the speech service. And as we said, we have text to speech. We can convert text to speech with a specific language, or taking the speech and convert it to text, either in real time or in reactive mode. I might have a big document, and this big document, I want to make it as a batch to be translated from a text to be narrated as a speech, okay? We have the third category about language understanding. This is a very important domain, especially if you heard before about the natural language processing. So when we are talking about natural language processing, this is a domain where we are interested to understand the language and what is the meaning in this language. For example, if we have a specific examples and we want to identify what is the intention of the user, what is the user intent, does he want, for example, to ask for a request, he might want to book a flight, he is requesting actually a specific service. So the computer can understand from the natural language, in any language, maybe in Arabic, in English, in Hindu, in any other language, can identify what is the user intent. And once it's identified, we can take actions based on this, okay? We have also text analytics, where we can analyze the make sentimental analysis for a specific text. Suppose you have hotel reviews, you have movie reviews, you have some reviews about books. You want to actually understand, let the computer understand if this review is negative or positive, or maybe it's neutral. So this kind of sentiment analysis is also widely used, and it's part of the language service or language understanding here, okay? We have also decision. This decision has three subcategories, where we have an anomaly detection. This anomaly detection, if suppose you have, as we said before in the previous sessions, suppose you have a manufacturer line, and this manufacturer line has some products, and we want to identify in the real time while we are producing these products, if specific products doesn't have the right specifications, it has anomalies, or maybe we want to detect the abnormality in the weather. So we can rely on time series information collected for years to predict maybe we have some uncommon pattern or abnormality in the weather might come, and we can identify this in the time series as a trend. And also we can apply the same concept if we are talking about some abnormal action which might happen in a specific environment. This is also coming under the anomaly detection. We have content moderator where can identify if this comment in a forum is a toxic comment, or maybe it's racism, or maybe it's something not acceptable in this forum, like some adult content, and we want to identify this as part of the content moderation. And we might also put the human in the loop by notifying the moderator, the human moderator, that this is something has been identified by the AI model as something maybe contain racism or contain adult content or something like that, and the human being will be, as a moderator, will take actions based on that, okay? We have also a personalizer under the decision category. This personalizer is helping if you have a system and you have customers and you want to actually give them recommendations, personalized recommendations, or personalized content, or even personalize the services based on their real-time behavior. You can use this service to do that. We have also search. Under the search, which is the last category, we have some user queries, and based on these queries, we can make a specific specialized search. Okay, for example, if I want to implement a search, maybe a mini search engine, and this search will be specialized only to show results as images, or to show results as videos, or maybe I want to actually show the results about local businesses. This is also part of the search, and this will help you to build very specialized search that expose specific content based on the user queries, either in format of image, format of videos, format of news, or even, as we said, format of local business information that might show address about the local business around you, maybe what is the type of this business, and so on. So if you have a specific kind of business and you are interested to know in this specific region, do I have a chance to expand and extend my services in this region, so I can go and check if there are some other service providers like me doing the same business or not. This kind of search services is covering all of these use cases that we are trying to explain here. This is actually the landscape of the cognitive services. We can move on here, and this is actually also description for the same thing that we just talked about. If we move on, why we might need to use a cognitive service. First of all, you have actually built-in capability or machine learning as a service exposed to you as a web service. So in that case, you have something well tested and actually built by experts in the field, and you can just go and use it directly without building something from scratch. This will save your time, and also will help you to expand the capabilities of your applications without any hassle, and you will be actually confident that you will get good results because, as we said, it's easy to use. Actually what you need literally is to create the service and get the endpoint URL with a specific key, and once you have this, you can start consuming this from mobile app, from web application, from even IoT devices. Okay, so it's very flexible, it's very easy to use, and it's well tested because actually it has been built by experts in the domain, and it has good documentation. If you go to Microsoft documentation, you can find many articles and many tutorials about how to use cognitive services in general and how to use the different services that we just talked about. So if you are interested in the Face API or Face service, you can go and look for it in the documentation, and you'll find a lot of articles that explaining the idea, how to use, and also practical tutorials how to implement this in different scenarios. Here, let me start with this nice example as a motivating example, okay, just for motivation. Suppose you have this nice cow, and you want to use the computer vision API to analyze the image. So I will give the image to the computer, to my application, and I want to recognize what is inside the image. So this is a kind of analyzing the image. I will get actually here some tags or some categories for this image. So it's not only one category or only one tag. I have multiple tags here, as you can see, and every tag assigned to this image is coming with confidence. This confidence is all about the score or the probability of this specific keyword or this specific tag. So if I want to describe this image, I can describe it with all of these keywords from different aspects or from different dimensions, and every one of these keywords coming with a confidence level, okay? Even further, I can also describe the image. We talk about the image captioning. What is the image captioning? I will give an image to the application, and the application will use the computer vision API to describe the image. What is inside the image? What the computer see inside the image? So, for example, this is sample descriptions for this image, and all of them actually make sense. You can look here for the first description: a brown cow standing on the top of a lush green field. A cow standing on top of lush green field. A large brown cow standing on top of lush green field, okay? And as you can see on the left side, every description coming or every caption coming with probability or confidence level, okay? This is one nice example in the computer vision field. And let me start now the demos, because we have a lot today. I will start from the Cognitive Service portal. So let me switch to Google Chrome, to the browser. Here, if you can see now the browser, this is actually where you can go and check the portal or the website for cognitive service, okay? This will help you actually as a starting point to know what kind of services you might use here. And it's categorized based on what we just explained in the presentation. You can find here decision as a category, language, speech, vision. Let's start from the vision. Vision here has computer vision, custom vision, and face. These are the main services that we have under the vision category, okay? So for the computer vision, suppose I want to test, I want to see actually here, what can I do with the computer vision service or computer vision API? Let's go here and scroll down. You'll find here a nice sample about the computer vision where I can do multiple things. Let me first show you what is the operations you can do. Here, I can analyze image like the cow, the nice cow or the brown cow we just saw now, or I can read text from image. This text could be handwritten in the image, or could be actually printed in the image. So I want to extract this text, and then I can use this text later for multiple purposes. Or I want to recognize celebrity or landmark in the image. Suppose if I have Messi in the image, or I have Leonardo in the image, actually I want to identify who is the celebrity or what is the landmark. May I have Eiffel Tower in the image or a specific well-known entity or location? So I want to recognize. This is a kind of recognized celebrity. Let's try this, okay? So if I go to recognize celebrity and I actually go here to upload, and I will browse from my machine. Let's go to desktop. I have here Obama, okay, Barack Obama, okay. So that will be uploaded, okay, and immediately we get the results here as a JSON result. This is a JSON object where you can see here, okay, this is the celebrity and the name is Barack Obama, and what is actually the face rectangle here. These are the left and top, width and height of the face itself. And this is the confidence levels that we talked about, 99.9. Okay, so it's highly confident that this is Barack Obama. Okay, We can do the same with another image here. So let's pick Donald Trump. So I can see, yeah, this is Donald Trump with this confidence level, and we have also the face rectangle around the face itself. And also we will see very soon when we come to the face service, if we want to specify the face landmarks, the nose, actually the eyebrow, and the different locations or different landmarks in the face, we can also do this in the service itself. And then we will see also the similarity between the different images in faces. Okay, we can also switch to read text. So suppose I want to read text from an image. So let me add this image. And I want to read text. This is actually a text on the image. And once I uploaded this image, I was able to see that the preview of the text this text has been extracted from the image. This is printed, not handwritten. Focus on progress, not perfection. This is the exact thing that I get here as a text. Okay. I also can insert URL here instead of uploading an image. And as I said before, in analyze image, you can notice here that we have here the results coming about the objects within the image. So we can classify the objects within the image, and we can also detect the location of these objects within the image. These are two different things. We have image classification, where we can classify there is a man in the image, but where this man is located within the image, this is another thing, we call it object detection, where we can draw bounding boxes around the objects to identify where exactly this person or this specific object is located in the image. Okay, we will see this also in our demonstration when we come to the Python SDK and how to use this from our application. So this is a nice introduction about the service. Let's jump to the Azure portal. And here in Azure portal, you can see I have created already some cognitive service resources. So we have multiple resources here. I will start here from the cognitive service. This is a cognitive service. This is a generic cognitive service where we can use it for multiple purposes. We can use it for image classification. We can use it for text analytics. We can use it for sentiment analysis. We can use it for some functions related to object detection as well. So this service is easy to create. It's not required actually to show you how to create, but just for if someone has no experience with Azure portal, quickly you can go here, and from the left side you can create a resource. And under the category of AI and machine learning, once you come here, you have something called computer vision, and you have text analytics service, and you can actually go and search for cognitive services. Okay, if you go to cognitive service, this is a generic cognitive service, but if you are interested only on computer vision, you can create a specialized resource for the computer vision, or a specialized resource for face, or specialized resource for text analytics. But this is, as I said, this resource will cover multiple purposes. That's why I'm using this here. Then we will move on to other resources as well. So you can create it from here. And you have this screen where you specify, okay, by default, this is your subscription. I have one resource group here created, so this is only just a container for my resource. And my region, we have, in Azure, we have multiple regions around the world. So definitely, I'm going to host my service in nearby location or nearby region, but I'm interested to keep it in West Europe. Okay. So this is the region where I'm going to host my cognitive service. Then I give it a name. Okay. And I specify the pricing tier, standard S0. Then check this checkbox to agree on the notice below, and then go and create. Okay. That will create a cognitive service resource for you. And this is, as you can see, this is easy and simple. But now, once you have the service, what you're gonna do with this service, okay? if you navigate here, we have a cognitive service created, which is this one. From the left blade, you can see here something called keys and endpoints. If you navigate to keys and endpoints, you will notice that we have 2 keys generated by default. Okay, those 2 keys, we can use any of them to authenticate our service call. And the endpoint for this web service or this REST API is this URL. So all what you need after creating your cognitive service in Azure portal is to get the endpoint, okay, the URL of your service, and grab the key, then go anywhere, either from Postman or maybe I'm a .NET developer and I want to consume this service in my .NET application. Maybe I'm a Python developer and I'm interested to use Python SDK to consume this in my Python or maybe Flask or Django web application, whatever, you name it. We have a lot of SDKs supported here and a lot of languages supported here where you can consume, because it's a standard REST API service. That's why you can consume it from almost anywhere. Okay. In addition to the SDK itself, we will differentiate between the SDK and call this as a pure service in our demo. When we go to the .NET application, I have here today a nice .NET application, and I will show you how to consume this service from there. Okay, so this is what you need, and you can get it from here, from keys and endpoints. Let's move on to one of the demos I prepared for today. Okay, about computer vision. So I have here, I will start with this .NET application. I'll switch to my .NET Core application just to consume the service. So let me switch to the Visual Studio. Okay, so here, if you notice, this is a normal .NET Core application where we have actually an action method called upload. Here in this simple method, we have 2 ways to consume our face API or face service. We have the SDK, which I commented out, and this normal HTTP call. Using the HTTP call, what we need to do is actually just to specify the endpoint URL, some headers, and provide the face API key that we talked about from the Azure portal, okay, to authorize or to authenticate the service call. And then we call post async and pass the URL of the service, including some query string parameters like the return face ID. So the identified face will be actually recognized by a specific GeoID. Return face landmarks true. This means that the result also will show the landmarks of the face, like nose, eyebrow, the position of the mouth, and so on. Okay, all the landmark of the face. Return face attributes like age, gender, smile, glasses. Okay, if this person putting glasses or not, and also the emotions. Okay, here we read the result as a content, then read this as a string. This is a async call. That's why we are awaiting it here, and return the JSON response from this method. Okay, so if we go back here and just share this running application, if you notice here, I have my application running. Okay, the same MVC.NET Core application that we talked about, and you can see my face. And let me smile and take a picture, okay, from this video stream. No, this is not the smile, so let me smile. Upload the picture. Okay, here we go. So we get the result immediately from the service, okay. I have a smile, so it's 100% confident that I'm smiling. The gender, the age, I'm not putting any glasses, that's why no glasses. Emotion, the only thing that I have here that I'm happy because maybe I'm smiling, and this is what the model actually returned from the face service API. Okay, so this is one way of consuming the face API. using this face API client, okay, we can, as we said, we made this as, let me stop this. And let me go back again to the Visual Studio. Yes, here also we can see that there is another way of dealing with this. If I get this from the face client, okay, so if I uncommented this one, okay, and comment this, so this is another way of calling this, how to actually get the result from here. This result will be actually serialized. We can serialize it here as JSON serializer. Yes. And we can use NewtonSoft. Okay, JSON dot, and here we have JSON serializer, and from the serializer we actually converting, yeah, JSON convert, yeah, and here we get this and deserialize the object. Okay, that's supposed to take an object, it's a collection. So I think we can make serialize object and give the result. That actually serialize the specified object to JSON string. Yes, okay. So that should be fine. But in that case, I commented the HTTP client call and I directly use the SDK here, this NuGet package for the face API, for the face service. And I defined here the face client object. I passed the endpoint and the API key. And I also specified here the same parameters that we have seen in the other call, which is using the HTTP client. And these attributes are similar somehow, like again, face landmarks. Actually here also showing the age, gender, smile, emotion, and so on. Then if we run this now, again, let me reshare again. Once it's running. Yes, here we go. So if I take a picture, upload the picture, here we go. So we get the results here that about my age, expected age, gender, smile, I'm not smiling this time, and that's why in the emotions, the model classified my face as neutral by 99.5%. And these are other things that we actually passed to our service call. So with that, actually, we have two ways here in .NET Core just to elaborate or explore what is the different ways of consuming the face API or the cognitive service in general, either from Python or from SDK. As you have seen here in the code, we actually have demonstrated these two ways. As you can see, the first way is using the NuGet package for the face API, and the second way is just make a standard HTTP client call. Okay, I have the same here in Python. Okay, so this is a Jupyter notebook where we can show the same idea from Python. Okay, so here I have this code. I'm using the same API key and the same endpoint. Okay, and I'm actually trying to analyze this image. If I use this image and I give it to my service using the URL of the service and the key, okay, I can see here that the image will come with a description, okay? See, I'm running this cell now. I'm getting this description here from the service that a woman showing her phone to child, and the confidence level of this analysis is 39%, okay? So the idea here that we was able to describe the image from the code using Python code, same thing, okay? And at the end, we get the description. We might also interested to get some analysis for this service, from this service to another image here, also as a description. So I can see that the description, this person is playing tennis, and the confidence level is 59% or 60%. And also, I can, like what I said before, we have visual description to the image. We have visual features. In these visual features, we can actually ask for more about the image. I need to identify faces. I need to identify objects within the image. I want to actually see if this image contains any adult results or not, any adult content or not. I need also to extract what is the best tags or keywords about what is inside the image, in addition to the descriptions that we have seen before. So for example, in this sample image, we get the result directly from the service with only one service head, okay? This is the description, and what is inside the image, we can see here that because we asked it for classification of the objects within this image, so we was able actually to see what is inside the image as naming for the objects. So we have a rectangle here. This is a person, and this person has a bounding box around its location within the image. This is the object detection, and there's captioning, or there's a description for this image. And in addition to that, on the right side, if you notice, we have here the rating. Is this image contain adult content? No. Is this image has any races? No. If we have specific tags, what is the best tags or keywords which describes this image? We have here person, we have clothing, we have shop. All of them actually, if you look well to this image, you will find that a lot of things actually well described here from the cognitive service. If, for example, just for trying other examples here, if I take this image and instead of that, I will put it here. So let's see what we will get. So here, very accurate, bounding boxes around every single object within the image. As you can see, we have the person. There is a bounding box or rectangle around the person, and we have here the shirt, the tennis racket, the shorts, the hat, and also the very accurate keywords or tags about the image, like sport, athletic game, outdoor, tennis, person, and same idea for the rating about adult content or races, in addition to the caption. This is actually all what we can analyze in the image, either just analyzing the image in general, or detecting objects within the image, or even if we want to actually put bounding boxes around the exact location of these specific objects within the image. Okay, so this is actually covering a lot of things around the computer vision. But if we go back here, we can see also we have another notebook here, Jupyter notebook for the object detection, where I'm using custom vision resource. In this custom vision resource, I have two resources actually created for that purpose. One for training, custom vision. This is for training, and this is for prediction. How can I build this actually? If I want to actually train a machine learning model or AI model that can recognize specific objects, and I want to train this as a custom model or the custom vision model, I can actually go to the customvision.ai portal, okay? In this customvision.ai portal, you can create project. In this project, you will upload the images that you want to train your model on. Here, I created a dog breed classifier. This project is a classification model where can identify what is the breed of the dog. So here, I added these images. Okay. This is the images that we have. If you notice here, we have 3 tags for each breed of the dogs. Okay, we have 16 image uploaded for Afghan Hound, Akita, 23 images, Bulldog, 30 images. So these actually are the training data that I used to train this custom vision model. Okay, and after I trained the model, I get this performance. Okay, about the precision, recall, and accuracy of my model. Then I can also get a prediction URL or even test this model within the portal itself here. And by the way, just to show you how to build such a model, okay, let me first show you how to test from here. So if I go and search for Bulldog image, and I took this image, any random image from here, and I go again to the computervision.ai portal, if I put this, the URL for this image, let's see what we will get. This is invalid image resource, so it's not actually a valid image resource. Let me get another one, just to make sure that we are providing right image, because this is looks like a URL without image inside. This is also not a valid. So if I go and just open this, okay. Or I can get it from the samples that I used before. This is the one that I used before, okay. Let me give it a try to get another URL with a valid GPG or PNG image. Let me see if this is a GPG. No, this is a page where we have the image inside. Okay, just need to test what we have here. Yeah, this is a GPG. Okay, so I believe that will be a valid image URL. So if we use it here, we can see what will be the result. Here we go. Yes, see, once I give a valid image URL, I get the results, the prediction of this model. By the way, this model took me exactly less than 10 minutes to upload images, actually to train the model and to get the final model and to test. Less than 10 minutes, literally, okay? So what I get here, that I give the image which unseen before by the model, and my model here was able to recognize that this is an American Bulldog, which is correct, absolutely correct. And the confidence level or probability of this classification is 99.3%. And we have the other 2 categories with very lower probability. So that actually show you how to even build a custom vision model, in the portal directly without writing a single line of code. Same idea here, I created another project for object detection. So this is object detection, where I have here these images, and I can test by browsing local files, and I'll bring this nice orange, okay? So inside here, you can see that my model was able actually to recognize that this is an orange inside the image, which a new image, which unseen before by the model. And every image within every object, every orange here within the image has been classified with a specific confidence level. And we have also the bounding boxes around each object. So here, this bounding box is an object detection mechanism to locate where exactly this object is shown within this image. So this is actually what we get here. And because as you can see, as you might guess, here we get this with the lower percentage because this is not something common, but here this is a higher percentage or higher confidence, and eventually this is the highest one because this is clear orange that the model has been trained on before. So we give here two custom vision models, one for the object detection and one for classification, okay? Multi-class classification. So this is about the custom vision. If I go back again to here, we have another Jupyter notebook for face analysis. This is very nice because you will see here a lot of things. First of all, I have the same thing. I'm using my endpoint URL, which I created here in the Azure portal. So if you go to the face-service, actually I created from here. If you go initially to create a resource and just search for face, you will get face. This is all about it. Create the face service. Once it's created, okay, you can go ahead and use the endpoint URL and the keys, okay? So this is what I have done, and I have one resource here called face-service, okay? And in this Jupyter notebook, I provided the endpoint URL and the key of this face service that I created in Azure portal. Then I have here this snippet of code where we are detecting the faces. This is the initial thing, just detecting the faces. Then, okay, let me just rerun this. Here we go. We are hitting the service. We are getting the results. I think here, yeah, here, this endpoint is not defined. There is no variable with this name. Okay, cog endpoint, because we didn't run this. Let me run this first. Yes. And then if we run this again, it should work. Here we go. So if you look here, the service was able to detect two faces within the image and put bounding boxes or rectangles around the faces. This is what we get. This is a face detection. So this is a similar scenario in the face service. Then we move on. We have another call called detect with stream, and here we just change the show faces here to show ID. Show ID here will assign GeoID GUID to each face. Why we might need this? Because if I assign a unique identifier or unique number to each face, I might have multiple faces, and I want to recognize and track this person for any other purpose. So suppose I want to actually compare between this user and other users in different photos, I can rely on this GUID or this unique number to track the user across multiple images if I'm doing analysis or comparing the similarity between the faces in different images. Okay, this is what we get here. We have two faces also, and each face has been identified here in the image with bounding box, and each face has been assigned a unique identifier or GeoID. Here, suppose I want to analyze the facial attributes and see the emotion and maybe guessing or predicting the age of this person in the image. I can do that actually by running this code. All what I need is using this face client object and call this method. And by the way, in the Jupyter notebook, if you just go and press tab, you'll be able to see all of the methods within this object. So you can see the properties and the methods within this object, and you can even go and check from here also by clicking Shift tab. You can see the signature and the description about this this method, what kind of argument list or parameters expected by this method, and some descriptions for these parameters underneath. Okay, this is a good way to see more details about each method and how to use it. Okay, here I'm passing the image as a binary stream, and I want to detect the faces again. But here this time I defined some attributes like age, like emotion. So I need to identify the face and detect the emotion. Maybe this person is happy, is smiling, and what could be the age of this person. Okay, so if I run this here, one face has been detected, so it's not that too much accurate because we get only one person face detected. Okay, and we get this information. We get that person aged approximately 32. He's not angry. He's not disgusted. He's not doesn't have any fearness. He is not that happy, but 98% is neutral, which is correct. Okay. Here also, the comparison or finding similarity between faces that we talk about. So I have here two different images. In each image, we have the same person, and want to see if the AI model will be able actually to make this comparison between the two different images and detect with specific confidence level, is this the same person or not? Okay. This is also what we are doing here. We get the image, we get it as a binary stream, we detect with a stream. We call this method from the face client object. Then we get the face object. Okay. Then we have another image where we again detect with the stream to get identify the face within the second image. Then we have the two faces, and we call another method called find similar. Find similar will take the two images, okay, and do the comparison to see if there is a match between the faces in the different images for the same person or not. So this person might be having a different posture or different position or different even emotion. But however, the system here, the model here will be able actually to find the similarity as we can see. So we hit again the service. What we get here, we get this lady is actually marked as match because this is the first image on the left side, and this is the right image on the right side. We are comparing. On the right side, we can see that there is a green rectangle around her face, and there is a match label to identify that this is the same person. Finally, we can recognize faces. So this implementation, we can do it actually for something like time attendance, biometric attendance. So I can recognize that this person is actually the employee name. So I can relate this face to a specific employee, and I can collect few images or few photos for my employees and actually train a simple model to identify the person within the image and relate this to the employee name. If we check here, we can find that we can create something called person group. This person group, actually, here we are creating the person group called employees. Okay, this person group will be stored in Azure, and we can add photos within this group. So this simply we create the person group. Okay. And here I have one employee called Wendell. I will create a person within this group and upload images for this employee, this person, okay, by this call. So Wendell here, within this person group, I create a person object and I give him a name, Wendell, his name. And finally, I will be able to see after adding some images to this person, okay, that I have, okay, these different pictures or different photos uploaded for the same person, just to make sure that we get a good accuracy of our model. Then we train the model using the face client also. So we call face client.person group.train and give the group ID. This group ID is a container of all the photos that we have for our employees, okay? And then once we run this simply, the train method will do the simple training because we have only this person with 3 images, so it will not take any time for sure. And then we pass another image just to test what we have, to recognize if the system will be able to actually identify and recognize this person as Wendell or not. So I give another photo. And here we go. This is another photo which we didn't train the model on. These are the images that we trained the model on. And we get here the image which has this rectangle around his face with the name, okay? So this is face recognition where was able to recognize the face in the image and associate it to a specific person, okay? This is another scenario. Last thing here, related to the receipts. Suppose I have a receipt and I want to recognize the content of this receipt, okay? So we have something called form recognizer, okay? We can use this form recognizer as part of the cognitive service to recognize the different items within the receipt. So I have nice thing here. So I uploaded this Google receipt, okay? And I want to parse from this image, what is the items that we have in this receipt, okay? So if you notice, all what I'm doing here, I'm just displaying this receipt, okay? Just to see how it looks like. And even it's twisted because it's rotated in the wrong side. However, we see now that the service will be able actually to analyze the receipt and extract the data and give us the item lines within this receipt along with the different prices for each item and even the total in this receipt. So this receipt, if you can recognize with me here, okay. All what I'm doing is giving the endpoint for my form, okay, and give the key, okay, form recognizer service, which is actually cognitive service also. It's nothing different here. And then forget about this cell. I'm just installing Python package because it's required here in this cell. But this is something else. Here in this cell, we are creating an object of something called form recognizer client. After importing this packages, we imported here this class form recognizer client and something called Azure key credential. And then we created an object of this form recognizer, okay? We pass the same image, okay, as a binary object or a binary stream. Then we call a method here called begin recognize receipts, okay? Begin recognize receipts. Even if you can see here from the autocomplete in the Jupyter notebook, you can even make a recognition of business cards or content from URL or custom form or identity documents or invoices or receipts. So you have multiple different implementations actually within the form recognizer, which you can make use of depend on your use case, okay? Here I have a receipt, so we call begin recognize receipt, and we give the file stream for this receipt. Then we get the results, okay? This results is receipt data, and we keep actually going through the receipt data. So I'm here fetching the receipt type, the merchant address, merchant phone number, transaction date, items. If any of these objects or these properties are not actually doesn't exist within the receipt, it will be actually ignored, and the final result will be the things that the model was able to detect from or to actually extract from the receipt. So let me see here what I'm get if I run this cell. You can see here also the items of the receipt and the total price and the subtotal and the tax, if there is a tax within this receipt. So if I run this cell, Control Enter to run this cell, analyzing the receipt, as you can see. Here we go. we get from our receipt, okay, all the receipt items, and this is really what I have, okay. This is one iPhone item, I have USB, I have one case for this phone, and so on, and also each price for each item and the total of this receipt. So this is actually the items that we get from the receipt analysis using the form recognizer. With that, actually, we completed our demos for today. And thanks a lot for joining me in this session. And I wish you a great night. Goodbye.